Hello, I am Manjunath from Government Engineering College. I welcome you all for this session 6 on the subject Computer Organization and Architecture for the Module 3 and Session 6. This presentation is a part of LMS of the Department of Collegiate and Technical Education. So, table of content. So, in this session, we are going to study about bus arbitration in DMA. So, before going further, I will review what we have studied in previous session. In previous session, we have studied about DMA, Direct Memory Access. In DMA, without active participation or without involvement of processor, data transfer takes place between memory and I/O devices. So as processor is not involved in this operation or process, a special circuit called DMA controller is used to perform transfer of data. We need usage of buses. So here DMA controller helps in getting the control of buses. There are two methods in which DMA operation can be performed. There are burst mode and cycle stealing mode. In burst mode, a block of data transfer takes place. For this scheme, processor gives control or processor gives permission to use its buses to DMA controller. DMA controller makes use of buses for the data transfer. So in this burst mode, processor has to wait until the block of data exchange has to take place. And then there is one more method called cycle stealing, in which access of the bus is taken over by DMA controller when processor is not using buses. That is, processor is doing execution operation. The buses are taken over or stealed by DMA controller. So this is what we have seen in previous session. That is what you mean by DMA. what are different types of DMA and use of DMA controller. Now we go on to the bus, what is called bus arbitration in DMA. So this bus arbitration is a conflict resolving scheme. So we can go and see what is what is the conflict that come across in this DMA and how it can be resolved. So there are two methods in which the bus arbitration can take place. First is centralized arbitration. Next one is distributed arbitration. Centralized arbitration is the process in which device raises the bus request signal. In turn, processor sends away bus grant signal, and after receiving bus grant signal, devices raises the bus busy signal. This is what the concept behind centralized arbitration. In distributed arbitration, devices have given identification and a pattern is generated in arbitration lines, and this pattern and the identification of devices compared and access is distributed or given to the device. So let us see the definition, what the definition tells. Bus arbitration is the process by which the next device to become the bus master is selected and bus mastership is transferred to that device. So it is a process by which the next device to become the bus master is selected. So here it is the bus master, as I told, it is the conflict resolving scheme. So to resolve the conflict, it uses the concept of bus mastership. So when the bus mastership is transferred to a device, that conflict can be resolved. There are two approaches for bus arbitration: centralized and distributed. In centralized arbitration, a single bus arbiter performs the required arbitration. In distributed arbitration, all devices participate in the selection of the next master. So here, in centralized, a single bus arbiter performs the required arbitration means by sending a busy. So after a device gets the access, it can send a bus busy signal so that a further assessment of the any further device can stop. In distributed, all devices participated in the selection of next bus master, in the sense, as I told, a pattern is generated and it is compared with the identification of devices. Now, in centralized arbitration, a single bus arbiter performs the required arbitration. Here the processor is the bus master and it may grant bus mastership to one of its DMA controller. Here, as I told, the conflict may be between two devices or between devices and the processor. When processor is involved, it is the bus master and it has to assign bus mastership to any one of device to the DMA controller. The processor contains the bus arbitration circuit. So a bus arbitration may be inside or it may be a separate circuit. So it is a generation of the signal. Now we can see one key of centralized arbitration using daisy chain approach. So daisy chain means that is arrangement of devices serially. So in this, first the devices raises this bus request BR bar and that enters this processor. In turn, processor sends out bus grant. So whenever device requires the use of buses, they send out bus busy bar signal. This was the approach used. Now we can see the bus request line. This is a wide R line. So many devices have been connected or wide R, and a bus request line is generated from all those devices. The controller only knows that a request has been made by a device but doesn't know which is the device made the request. Bus grant line. This line is propagated to all of the devices in a daisy chain fashion. So this bus request is generated by the devices, and in turn bus grant is generated by the processor, and this line propagates to all of the devices in a daisy chain fashion. A DMA controller indicates that it needs to become the bus master by activating the bus request line BR. So if any device needs the bus to the DMA controller, they activate the bus request line BR, or they send out the bus request line BR. After getting bus request signal, processor activates bus grant signal. It indicates DMA control that they may use the bus when it becomes free. The PG signal is connected to all DMA controllers using a daisy chain arrangement. If DMA controller is requesting the bus, it blocks the propagation of the grant signal to other devices and takes the control as bus master. So a DMA controller is requesting the bus, it blocks the propagation of the grant. So it is the grant. If the grant signal is blocked, that means it is used by any device, and it can use and it may become the bus master. Otherwise, it passes the grants. If it doesn't need, the bus grant is passed away to the further. It will go to the next device. This operation continues until the BG signal reaches the last device. So this is a concept. So after receiving the bus grant signal, DMA controller which wants to take control issues bus busy signal to processor and all the DMA controllers. DMA controller waits for bus busy signal to become inactive. It then assumes mastership of the bus. DMA controller now activates the open collector bus busy line BBSY bar. It indicates that it is using the bus. So this, by using the sequence of signals, this bus masters can be used or it can be transferred like this, in this fashion, by using this type of signals. Now in terms of this waveform or clock, the sequence of events using a timing diagram. So in terms of timing diagram, you can see the events in becoming the bus master. What are the events? First is the bus request. Now here afterwards, when it reaches the processor, bus grant is generated by the processor. So like this, different bus grants. If there are many number, there it may go like this: bus grant 1, bus grant 2, and if any device is using the bus, it will send out the bus busy signal. So then it becomes the bus master. So now in the step 4, DMA controller had requested for the bus. It waits for bus busy line to go high, that is waits for processor to release the bus. In the step 5, DMA controller 2 asserts bus busy bar signal low. takes control of the bus and proceeds to complete data transfer. Step 6. After the operation, DMA control releases the bus by making busy bar signal line high again. No process becomes the bus master again. So here, when this bus after the when the DMA has completed its task, that is the transfer of data. Now on bus busy bar, it sends a high signal on bus busy bar. Now the bus master again goes back to the processor. Now you can see the distributed or decentralized arbitration scheme. In this, all devices participate in the selection of next bus master. So a simple arrangement can be seen here. So here, so this for different devices, identification has been assigned here, like ARB0 bar, ARB1 bar, ARB2 bar, ARB3 bar, like this. And there is one more arbitration line. So it is interface. Now we can see the operation. So each device on the bus is assigned a 4-bit identification number. So identification number is assigned to the devices. When one or more devices request the bus, so what happens, you see, they assert the start arbitration signal and place their 4-bit ID on 4 open collector lines. So ARB0 to ARB3. The signals interact with each other and fill the code on the 4 lines represent the request that has the highest ID number. So that means here we can see the signals interact. So here the signal means the identification and the code. They will interact with each other. Now if the input to one driver is equal to 1 and the input to another driver connected to the same bus line is 0, then the bus will be low on low voltage state. So we can see some illustration with some example of taking the, so here let two devices A and B are requesting the service having ID numbers 5 and 6. So here in example you can see ID number, let ID numbers be 5 and 6. So we can see the illustration with these numbers of two devices as 5 and 6. Device A transmit the pattern 0101, so that is 5, and device B transmit the pattern 01106. The code from A is 1010 and from B is 1001 due to NOT gates. So the final code on the arbitration line is 1000. Since the arbitration lines are active low, the code seen by both the devices is 011. So this was the scheme of 5 and 6. This was what generated. Each device copies the pattern on the arbitration lines to its own ID, starting from most significant bit. So like this, if it is detected a difference at any bit position, it disables its drivers at the pin bit position. So this is the scheme if the device having the numbers 5 and 6. So by this we have seen the two methods, centralized and distributed arbitration scheme. So this is the arbitration is the conflict resolving scheme. Conflict in operating the bus mastership. Conflict arises when more than one devices or more than one devices and processor try to become the bus master. So that is resolved in the two schemes like centralized and distributed. So in centralized, sequence of signals will be generated like bus request, bus grant and bus busy. In distributed, so identification is given to the devices and a bit pattern is generated on the arbitration line. Now we come across to enhance the understanding, we have come up with some multiple choice questions. So dash is the process by which next device to become bus master is selected and bus mastership is transferred to that device. So dash is the process by which the next device to become the bus master. So with the concept of bus master, we have seen the conflict is resolved. The scheme is called bus arbitration. Next question, the two approaches for bus arbitration are. So we have seen the two approaches are centralized and distributed. There are two approaches to resolve the bus conflict. The scheme is arbitration. In dash arbitration, a single bus arbiter performs the required arbitration. So in centralized arbitration, single bus arbiter is used. Now in dash arbitration, all devices participate in the selection of next bus master. So in distributed, so it is distributed for all the devices. BR stands for bus request. BG stands for bus grant. BBSY stands for bus busy. So in daisy chain arrangement, dash device has highest priority. So the device far away device in made a device closer to processor physically, because it passes the signal, the grant signal passes serially. So first it goes to the device which is nearer to the processor. So these are some multiple choice questions and these are the answers. Now we have got some exploratory questions. Write a note on bus arbitration. So bus arbitration is a conflict resolving scheme. So it resolves the conflict of who becomes the bus master. So it uses the concept of bus mastership and resolves the conflict of who wants the bus mastership. So there is centralized arbitration, and so it uses the series of signals to assign the bus mastership, and distributed arbitration scheme is used in which identification number is assigned to devices and a pattern is generated on the arbitration line and it's compared and it resolves. Now we have got references. We have got the reference book is a computer organization, 5th edition by Tata McGrail, author Karl Hamacher, Zonko, Rensick and Shafar Zaki. And now we have all the slides are prepared based on internet resources and reference materials. Now I come to end of the session. Thank you. Our LMS team, Dr. Rangaraju, HOD ECE Department, SKSJTI Bengaluru and his chairman, LMS ECE courses, Dr. Nilapa, HOD ECE Department, GEC Kushalnagar, Professor Kushananda L, Assistant Professor, ECE Department, Government SKSJTI Bengaluru is the LMS moderator, and myself, Professor Manjunath, Assistant Professor, ECE Department, GEC Kushalnagar. Thank you.